So we've got a battery that you have access to via an app.
Yep.
A battery that puts itself to sleep when you park the motorcycle to conserve whatever energy it has, so that if you come back in, what length of time can it?
4 or 6 months.
Okay, so you can sit there for 4 or 6 months.
Maybe longer. Maybe longer, yeah.
Maybe longer, okay.
Yeah.
I'm just here with Tim Lennon from R&J Batteries, and Tim is the man behind a new secret prototype battery that's been put into my bike, and it's been in my bike for the last couple of weeks. And we're finally at a point where we can start talking about it, aren't we, Tim?
We are. We can start to fill it out a little bit.
Can you tell us, first of all, Tim Lennon from R&J Batteries, thank you for coming here. And
thank you for your time.
For putting the battery in my bike. Can you tell us a bit about what prompted you to make this battery?
There have been, I think, previous attempts at lithium batteries for motorcycles with limited success, varying success. The market demand from time to time was there, and we would get requests for a battery, a lithium battery for a motorcycle. So our challenge was, if we're going to do it, we're going to do it properly. One of the mottos that our company has as one of its values is do it once, do it right. So from the very outset, we said, well, if we're going to do this, let's actually come up with something that's going to work really well.
Now, the perception, what I've seen from comments in my videos, is that I do see negative comments popping up from lithium ion from people who've had bad experiences. Talk a little bit about the history of where you've come from regarding lithium ion, and what products you have tried, and what worked, what didn't work, and how that has shaped you coming to where you are at this point.
So lithium batteries, or lithium ion batteries, if we look at a scope of lithium ion batteries and all the different types that there are, there's actually quite a broad spectrum. But there's a couple of subtypes that are a little bit different. So one of the subtypes is lithium titanate, which is used a little bit for energy storage and incredibly stable, but can be quite heavy because its energy density isn't as high, but really high cycle life. And then there's another subtype called lithium iron phosphate. Lithium iron phosphate sits in a little pocket all by itself. It doesn't quite have the energy density of the other lithium ion type batteries, which generally will have nickel, manganese, or other elements like rare earth elements to give them their high performance. Cobalt's another one that comes up. They don't have any of them, and so they don't have quite the energy density and performance, but what they do have is stability. The phosphate gives them incredible thermal stability and also a really good cycle life. So it's a nice little pocket where you've got a battery that performs extremely well, safe, stable, and predictable.
So lithium iron phosphate, so they're the ones that are most safest in terms of battery fires and things like that. Is that correct?
Yeah. So whenever you see a lithium battery on fire, you can rest assured it's not a lithium iron phosphate. It'll be one of the nickel, manganese, cobalt combinations. They tend to be much more reactive, and they get thermal runaway much more easily. So when we say thermal runaway, basically what happens is the battery starts to get hot, and it can't shed its heat fast enough, so the heat then starts to accumulate in the battery to a point where it will ignite, and then you've got a battery fire. Some of those combinations of batteries can start to get thermal runaway below 100 degrees Celsius.
Okay. When you say 100 degrees Celsius, we're talking like outside temperatures or the actual temperature of the battery?
Temperature of the battery, yeah. The temperature of the battery, they can start to get to a point where they can't get rid of the heat fast enough, and the heat intensifies, and then they get that runaway and start to smoke and then ignite.
But this battery has none of that. Yeah.
No, you don't want a little firecracker under your butt when you're riding your motorcycle or your quad or whatever you're going to use the battery in. So safety was paramount if we were going to do this properly.
The big thing that attracted me to this battery when you first brought it to my attention were the smart features. Can you tell us a little bit about what this battery can do, because it's pretty clever?
Again, we really challenged ourselves to do something a little bit different. Rather than just make another one that's the same or almost the same as everything else that's around. We really wanted to excel. So we wrote a shopping list, like a nice to have, of all the things that we would like a battery to have, and partnered with one of our major suppliers, and they have some experience with lithium batteries and actually have a sister company that produces lithium motorcycle batteries currently. So they had some technology available to them. So we sat down and said, is it achievable that we could put all of this into a lithium battery for power sport applications, and get these smart features in, things like the ability to communicate with it via Bluetooth, so that you can adjust the settings of the battery and also see the status of the battery, see how much current is being drawn, for example, see what the voltage is, see what the cell balance is, things like that. And they tick that box. We also wanted a battery that could conserve energy. So one of the key issues with some of the previous versions of lithium batteries is they would put them into a motorbike, and as we know, lots of people don't ride their bikes over the winter season, and so they would sit there with a small parasitic drain, and the battery would be drawn down to a stage where it couldn't be recharged. So then the battery became more of a house brick. So that's a really bad experience for a customer. So we wanted something that would be smart enough that it would automatically hibernate and conserve enough energy so that when you woke the battery up, there was enough energy in the battery to start the bike or the quad or whatever you're using it in, not having to use a jump starter or charge the battery first. Because when you come, after you haven't ridden your vehicle for a while, you want to wake it up, you want to go for a ride, you don't want to have to muck around with jump starters. And we prefer to not have to use jump starters in any application, especially in modern, not only cars, but motorcycles. Jump starting becomes more and more controversial because it's something that if it's done wrong can potentially damage it. So this eliminates that.
And potentially damage ECU too.
Absolutely.
Yeah.
Absolutely. So by eliminating the need, or as much as we can, eliminating the need to have to jump start, not only simplifies it at all, but also makes it, again, more safer and reliable for the end user.
So we've got a battery that you have access to via an app.
Yep.
A battery that puts itself to sleep when you park the motorcycle.
Yep.
To conserve whatever energy it has, so that if you come back in, what length of time can it?
4 or 6 months.
Okay, so you can sit there for 4 or 6 months.
Maybe longer. Maybe longer, yeah.
Maybe longer, okay.
Yeah.
And then when you go to start it, the energy is just sitting there ready to go, and it doesn't need to be on a trickle charger?
No. It could be if you wanted to be, if you really wanted to be, some insurance, but yeah, you don't need to. One of the things that we've done with the BMS and the hibernation is you can actually adjust how long the battery waits before it hibernates. So say, for example, you've got a bike and it's been for a ride, so the battery's pretty well fully charged, and you have a hibernation delay of a week. Then after a week, that battery's going to go to sleep. It's going to hibernate with almost a full charge. So when you wake it up in 6 months' time, there's going to be plenty of energy left in that battery to start.
When you say hibernate, it's actually like the bike thinks it doesn't have or doesn't even see a battery there, does it? In terms of ECU and things like that, it's getting zero voltage from the battery.
Yeah. So the battery actually shuts down and goes to sleep. A bit like your laptop goes to sleep or hibernates, where it shuts down and becomes effectively inactive, and then you wake it back up. It's that same sort of concept. You can also adjust the sensitivity of how you wake it up. But if you don't want any of those features and you just want a normal battery, it also has the ability to go in from intelligent mode to what we've called normal mode, where it's just a normal battery. It doesn't have any smarts, no active sleeping or hibernating. It just operates as a normal battery with a low voltage cutout like a normal lithium battery would have.
And what is the process for waking the battery up?
Well, that's where we started to get really excited, because we wanted something, our criteria was on our list was something that you didn't have to access the battery and push a button or something on the battery. We didn't want to have to plug in a 12 volt or a 9 volt battery to wake it up using an external voltage source. We wanted something where you didn't have to have anything extra to wake it up, something where you didn't even have to make contact or access the battery. So the manufacturer that we're working with, we challenged them with this, and we had a couple of ideas, and none of our ideas were that good, clearly, because they came up with a better one. They came up with the idea of putting a vibration sensor on the BMS, so that when you move the battery or shake it, we've called it shake to wake because it sounds really cool. So if you shake it, so you get on your bike, for example, give your bike a couple of shakes, the battery will wake up, you turn your ignition on, you start your bike, and you go for a ride. The other thing that we've put in the app, as I mentioned earlier, is to adjust the sensitivity. So we've got 3 settings for the shake to wake, so that you can have it really sensitive, so it's a bit of a hair trigger and really easy to wake up. We actually mucked around with one of the bikes, and you actually give the battery a little bit of a bump like Arthur Fonzarelli, and the battery will wake up, right? Or you can have a sort of a normal sensitivity where you need to do something a little bit more aggressive, or then a really low sensitivity, which is effectively turning that function off as far as the shake to wake. And the reason we did that, for example, if someone's got a bit of a tight garage and they've got a couple of bikes and a car and they've got to walk past the bike all the time, when they're getting to the car and they keep bumping their bike, they would keep waking it up. So by actually putting it to low sensitivity, then it doesn't matter if they bump the bike, because you really need to shake the battery aggressively to wake it up. So you effectively stop the battery getting woken up every day as they move past the bike and bump it. So we tried to think of all the scenarios where people would want to customize the function for whatever their current application is.
Yeah, you've really thought this through, because every time we've got another question, you've got an answer. So that's awesome.
If we can keep that up.
Yeah. Now, for me, my own personal experience with the battery, I've been running it for a few weeks now, and I can't tell any difference in that I've kept my Indian battery on the trickle charger, ready to go just in case. But I've never even thought of putting that battery back in. It just fires the bike up straight away. It does start it up a little bit quicker, I reckon, than the standard battery.
Yep.
And yeah, I just have had didn't even think about it. I forgot I even put the battery in.
That's the right answer. That's exactly what a battery is. A device that when it works properly, you don't think about it. And that's sort of, I guess, part of the aim of the whole thing. Yeah. And you're right, it does start a little bit faster. So one of the characteristics of lithium iron phosphate is that it has a slightly higher voltage range, and it also holds a higher voltage under load compared to AGM batteries and other lead acid batteries, because it has a very low internal resistance. So if you have a higher voltage, that means you actually have a little bit more power. So it'll crank a little bit faster. So we've consistently had that experience with the bikes that we put them in.
And we were talking about cold starting, and you mentioned a really interesting point, which was counter to how a traditional battery works. Can you talk a little bit about what happens and what happens when you try and start cold?
Yeah. So lithium batteries, like other batteries, because all batteries are an organic chemical reaction, and as things get colder, they slow down. So just like lead acids struggle more and more as they get colder, so does lithium. Especially in North America, where it gets really, really cold. You see quite a few examples in Europe, but there are parts of Australia that get below zero. So when you get below zero, the lithium start to slow down like everything else. What you need to do is actually elevate the temperature, and the best way to do that is to turn the ignition on, turn the headlight on, maybe leave it on for 30 seconds.
That's counter.
Yeah. Try and crank the bike once or twice, and then let it sit for maybe another 10 or 20 seconds if it doesn't start the first time, because that'll actually start to just put a little bit of warmth into the battery because you've pulled some current out of it. Try again, and the second time, I have experienced, it always starts and off you go.
So for me, there's no way on the batteries I'm used to using that I would leave the headlight on for any period of time, especially if it's struggling to start. Yeah. I would guess, okay, that's not going to, if it's not going to start the first time, it's not going to start the second or third or fourth time, but it's opposite.
Yeah, no, you're right. It is counterintuitive. Normally, if you've got a bike that doesn't want to start, you're worried about conserving the energy. Yeah. I'm exactly the same. Yeah. It's like, turn it off. What can we do to get some more energy when you jump start it or something? But yeah, when the batteries are cold, you just need to warm them up. Now, for most of Australia, that doesn't really apply. Even in Melbourne and sort of Tasmania, we generally stay above zero.
So above zero is like that
pretty normal. Yeah,
it's just when you get say -5, -10 degrees Celsius, and I'll put up what the Fahrenheit is. Figures are.
Yeah.
That's where you would maybe need to give it a couple of starts and let the battery warm up a little bit, and then start it. Yeah.
So it's just, I guess, trusting the process. We've written a really comprehensive manual to try and cover all the questions that people will have, and we actually mentioned there about cold starts. And if there's a problem with a cold start, give it a couple of cranks, leave the headlight on, wait 30 seconds, go again, and off you go.
Yeah. And will there be a website that people can access all this information on the battery?
There won't be a dedicated website, but the R&J Batteries website, so rjbat.com.au, will have information, product data sheets. So we have product data sheets on most of our products, so I've already prepared them. It actually goes through the specs of each battery, so you can understand a little bit more about it. They'll also come with a user manual in the box that'll step through everything. And of course, you can ring us. So talk to our stores. We like talking to our customers. Give us a call. We'll find the answer out for you if we don't know it straight off the top of our head. So yeah, we always like talking to our customers.
Now, the app is going to be Apple and Android?
Yep. We've made the app for both Apple and Android. Looks almost identical, functions in a very similar way as you'd expect.
And what can you control from the app?
There's a whole lot of stuff that you can control. So firstly, you can monitor and look at the voltage, the current, the voltage of each cell, the temperature of the battery as well, because a temperature sensor inside the battery, so you can see how cold it is. There's also a summary that shows if any of the protection elements, so these are over current, over voltage, under voltage, over temperature, under temperature, all of those sort of alarms are on that front dashboard, so you can see if any of those have activated. You can then go and start making changes, so you can change the delay or the hibernation delay before the battery goes to sleep, how sensitive the shake to wake function is. Also, you can take the battery out of intelligent mode and put it into normal mode if you want to deactivate all the smart things. Another thing we've put in is we've put a really basic logging facility in there, so that if there's a problem with the battery, someone's having some issues with the battery, they can bring it into an R&J store, or they can have a look themselves. You just query the logs and it will bring up and show how many BMS events, if there's a current problem, a voltage problem, a temperature problem, and it will give you a count of how many times that's happened. Okay. It also sort of counts cranking events, so it looks at the voltage drop, and for lots of bikes it's not a guaranteed measure, but we sort of put that in there just so we can get an idea of how much work the battery's done and how many starts it's done. Yeah. So trying to get some basic data out of the battery to help understand if there is an issue, to help fault find it, because it doesn't matter how many times or how many different ways you try and find an issue. There's always a machine that does something different that you didn't expect, and so being able to work through it and understand it is half the battle. So we've tried to build that in. Yeah,
that's fantastic. And now, with the hibernation, like say if you set it to go to sleep after a day, and then you ride the bike 4 days later, and then you park the bike and it goes to sleep for a day, and then you wake it up and ride it 4 days, does that cause any issues to the battery, or it doesn't matter?
No, it doesn't matter. So there's no actual switching mechanism in the BMS. If we had some sort of switch that was switching on and off all the time, though, mechanical switches fatigue over time. Yeah. But the BMSs use MOSFETs, which is a sort of electronic switch that goes between high resistance and low resistance. So high resistance isn't technically off. It's just a very, very, very high resistance that acts exactly like it's turned off, because as soon as you try and put any load on it, the voltage drops to zero because of the high resistance. So it's a electronic switch that can do it thousands of times with no degradation.
Okay. Yeah. In terms of like the lifespan of the battery, how do you see it comparing to traditional AGM batteries or whatever's currently in the motorcycles currently?
Yep. Excellent question. So we're saying up to 3 times the life. I think that's a bit conservative, but we haven't had the luxury of being able to put the batteries in bikes for 3 or 5 years to get some long term. So we've sort of simulated some of that life cycling to try and understand it. We also have experience with lithium iron phosphates in deep cycle batteries in caravans, etc. at R&J batteries. So we've sort of pulled on our experience from that as well. Some manufacturers will make larger claims and bolder claims on the life. We've gone conservative and just said up to 3 times the life of what you're currently getting, because we think that's achievable and realistic.
And price comparison to a standard motorcycle battery versus your new battery?
You get nothing for nothing, Paul. They are more expensive. If I had to pluck a number out of the air, I'd say they're probably 2 to 2.5 times the price of what you're currently paying at retail. When you do it's a bit like caravans with lithium iron phosphate batteries. They're expensive. They're 2 to 3 times the price of an AGM. But when you actually look at the number of cycles you get out of them, do a cost per cycle or a cost per start or something, the costs are significantly lower. Yeah. So in this application, it'll be probably cost per start, which translates into lifetime anyway. But it's like most things, there's such a variation. Even in a normal motor vehicle, the same battery will see one vehicle, the battery will last 2 years. The exact same battery in a totally different application, but still a motor car, will see a 6-year life on a battery. And the only variable is actually the vehicle that it's fitted to and the usage pattern, not the battery itself. So the scope is pretty broad. Yeah.
Is there a weight saving with this battery?
There sure is. They're less than half the weight of a normal sort of AGM or flooded lead acid battery. Okay. The weight is the first thing that people will notice. When they pick one up, you go, whoa, it feels like the box is empty. The weight isn't significant for a motorcycle that weighs 200 kilos if you're saving 1 or 2 or 3 kilos.
Every bit helps.
It does. But it's the first thing you notice because the perceivable difference is so significant, yeah.
And size of the battery comparatively, is it smaller than your typical similar capacity battery?
Inside it is, but what we've done is we've picked, there are 5 batteries in the range, and so those batteries are the 5 quite popular sizes. And then on top of that, what we've done is added some spacers into the boxes as well, so you can actually space them up so each battery will actually replace multiple size batteries, because the power output of the battery isn't really an issue. They've got plenty of power, so we can put them into applications, but we still need them to fit the box or the enclosure properly and be able to hold down securely. So adding the EVA spacers enables one battery to replace more than one case size.
So you've done that so that you whatever bike you've got, it's a certain size battery. The box is designed for that battery. So when you put your battery in, it's very similar in the way it fits in to the standard OEM battery.
effectively replicates what came out as the OEM battery, because often the batteries will have, like, for example, a hold down over the top, a rubber strap hold down. So the battery needs to be the same size for that rubber hold down to work, because you don't want your battery bouncing around. So by putting a spacer or a couple of spaces underneath to bring it up to that same height, the rubber hold down works correctly, or around the side or wherever it goes. So then, it's sort of a like for like replacement as far as the case envelope that's sitting in the bike.
Could you see yourself doing down a track a battery that removes all that empty space? I'm just thinking for customizers who want a really small battery. Is that something that could be done in the future?
It's not something we've really ever thought about, I guess. Normally with most OEMs, the battery space is the battery space. I mean, you've just got my head thinking now. Could we do a smaller battery and then you have a little pocket that goes next to it to use that space to give you somewhere to put things? Yeah, a bit of extra storage space, because storage space is a problem with motorbikes at the best of times. So
well, yeah, for your standard road going bikes, but just like for choppers, custom bikes, which choppers are really starting to make a comeback. Where I'm seeing the channels I'm watching becoming more popular, I believe. And they're always looking to, make the battery box as small as possible and to hide it away and things like that. So I'm just thinking there may be a market there for that sort of thing.
Customers often find they never need as many CCAs as they think they do. There's a lot of talk about CCA. The starting power, CCA. Cold cranking amps. So the way that we measure how much energy the battery can deliver to start an engine. So some of the testing we did was on a Suzuki 1500cc V-twin Boulevard. And that normally has a sort of a 16 size or 16 amp hour battery, quite a large battery. We went through all of the battery sizes all the way down to our second to smallest battery, which is a 6 amp hour battery, and that started that bike quite confidently. So there's an opportunity there. Maybe they just pick a smaller size battery, and that gives them a smaller packaging space as well.
Okay, cool. Yeah. Cool. Now, we're going to have a look at the app, and we're going to have a little bit of a closer look at the battery.
Sure. So I thought we'd just do a bit of a demo and sort of show how it works. So we've got a sample here, a battery that's sort of been through the wars a little bit. We've had this battery for almost 12 months. I'm just going to put it on this lovely Royal Enfield Classic here. I'm using my showpiece. We've got an LED around the bottom just so we can demonstrate when the battery is on and off, so you can sort of understand it. So to turn the battery on, you can turn it on manually by pressing the power button once and then a second time and holding it, and it will power up. So now we can see the battery is turned on. We also turn it off the same way, so you can, if you've got contact with the battery, you can do that quite easily. But I can also use the app as well. So if you look at the app screen, that currently tells me that it's turned off for charging and discharging. So there are scenarios where, for example, you might have it okay to discharge and not okay to charge when the battery is really cold. So you can't charge a lithium battery when it's below zero. So this would show you if you looked at the app. And
below 0 degrees
Celsius. So lithium batteries don't like charging below zero because the electrolyte starts to crystallize. Okay. So that's why you got to warm them up before we can charge them. And that's all lithium iron phosphates and all lithium ion batteries. Okay. So this says it's currently turned off, so I can just use the app and turn the battery on. So this battery can be inside your bike and you don't want anyone to ride it. We joked about the scenario, you got a little brother who always borrows your trail bike. You could turn the battery off and he won't be able to work out how to turn it on because you can't even get to it inside the bike.
And the battery's paired to the app on your phone?
Yes. Yep. So you just go in and you can scan for the battery and then you connect to it. Each battery comes with a barcode and there'll be extra barcode stickers in the box. So if you've got more than one bike and you've got one of these batteries in each bike, you can actually go in and scan the barcode for the bike that you want to connect to. So it makes it quite easily. And all you have to do there on the app is, whoops, wrong button. We disconnect, so we can actually disconnect. So now we're not actually connected to the battery anymore. Here we can just pull down and do a refresh. Okay. If we had more than one, what we could do is actually hit the scan button up here, and then it uses your camera, and the camera will access the barcode, and then it will connect to the battery. So then there's a little handshake where they connect with each other, and then they'll come back on and start talking to each other again. So now we know we're talking to each other. You see the voltage of the battery. Currently there's 100 milliamps coming out because the LEDs are on. Here's your battery cell voltages, the temperature, 19.9 degrees. This is the status of any of your BMS events. Your settings, so you can query it. And it tells me currently this battery is set. So we actually have a setting called 0 days, which is actually about 3 minutes. Oh, okay. We put it in there for testing. Yep. And we've left it in there because there might be an application where someone wants it to turn off basically straight away. So we've left it there because it might be useful. this is your shake to wake sensitivity, and you might want to adjust it to normal, for example, and then all we do is confirm it, yes, and now it's confirmed.
And it's all very responsive too, which is great to see.
Yeah, it's good. It's waiting for apps can be a bit frustrating sometimes, but yeah. And then here's your intelligent and normal mode setting. So if you want to go to normal mode and just turn it into a normal battery where it doesn't do anything except act like as a battery, then you just use the normal setting to achieve that. Here's the logs, so you can actually query it. I don't think this has got anything in the logs right now because we've just done a firmware update on this battery. But if there'd been an over discharge, for example, or a short circuit, or it had been used to start a vehicle, like crank an engine a number of times, you would see other numbers there.
Fantastic.
So it's pretty straightforward and intuitive. We've tried to make it really simple so that you don't need to think about it every time you pull up the app. How does this thing work again? It sort of steps you through it pretty simply. So
now the big question I have is, when will it be available for people to buy?
That is a very good question. Shipping being what it is right now around the world, it's a little bit variable, not very reliable. We are anticipating that the shipment should arrive early November. We should have it in our stores hopefully by the second week of November. We're hoping for earlier, but shipping right now can be a little bit frustrating. So we don't want to overpromise and underdeliver. So I'm sort of saying maybe mid-November we should have it in stores. Yeah.
And now the next big question is, who will be able to buy it and where, in which country, etc. Like,
yep,
just where is it going to be available?
Yep. So obviously we're Australia based, so we're launching in Australia to start with. We also have a number of stores in New Zealand, so we will ship stock to New Zealand, so it'll be available in New Zealand probably December, I'd anticipate. We can get some stock over there. Currently that's the limit of our distribution and where we are. So it's nice for Australia to get something first, isn't it? Yes. Normally we get everything last.
For sure. Yeah, that is true. Normally we're a year behind everybody else, but it's so great to see this coming here first. Is there a potential to go worldwide with this?
I guess anything's possible. We currently don't have a distribution network in places like the US, but it's something that we've had a couple of conversations about. Nothing that I can sort of really talk about that's definitive or positive yet, but it's something that's definitely being sort of looked at if there's a way that it can be done. Yeah. But Australia, Australia, you know, for many companies, Australia is a really good testing environment for new products. So, you know, I guess we're fortunate in some ways. Australians are really good as early adopters, and they will test products and they will tell you what they think. So we're, I think, pretty fortunate to be able to have it in Australia and get something out there and get some fast learnings on it.
Now, is there anything that we haven't covered that you want to, anything else, or have we covered pretty much everything?
Talked about a lot of stuff, haven't we? Yeah, no, I don't think there's much else, except that, you know, it's, you know, this is a world first. There are no other batteries like this in the world with all of these features. There are other lithium motorcycle batteries in the world, or power sport batteries, but not with, for example, with the ability to communicate via Bluetooth and the shake to wake, which is something we know that no one else has got because we sort of dreamt it up ourselves, or our manufacturer dreamt it up. And the combination of all those features makes it something that's quite unique. Yeah. Fantastic. So that battery's gone to sleep now. So if you want to give it a bit of a shake, it'll wake up for you. Just pick it up or move it, or
I'll video you shaking it.
Tap. Oh, did I? Oh, maybe I put it to sleep. Oh no.
There it is.
Every time. I have this in my office, and every time I walk on the vibration, the floor sets it off.
Oh, really?
I thought I would just wake up.
Setting in the app.
Oh, maybe I did. Yeah, maybe I did.
I think you did.
Yeah.
I think you might change the setting of the sensitivity.
I did too, you're right. Because I hit confirm, but I didn't actually, like it's confirming that it says, you sure you want to do it, and you've got to say yes. I didn't say yes. Okay. So there's an outtake for you. If you want to do a blooper, there's a blooper for you. So now when it goes to sleep after 3 minutes, you'll pick it up and it'll wake up straight away. Yeah. I totally missed that because I was talking at the same time. Yeah.
All right. Well, thank you very much, Tim. And also thank you very much for considering me and my channel to do this. It's pretty cool.
And thank you for the time. I really appreciate your time and, you know, the openness and willingness to sort of work with us and tell us what your experience is, and, you know, obviously help spread the word that we've done something unique here, and, you know, we sort of want to get the word out. But the early or the advanced testing is, you know, really valuable to us. We currently have probably 6 or 7 bikes running around Melbourne, different types of bikes, adventure bikes, big cruisers, all running these batteries, trying to get some early learnings and understand what the characteristics are. So,
which is great. You know, that's the best way to test it, I reckon. Just put into bikes in real world situations and see what happens.
Yep. You can test in the test lab as much as you like. You can try and simulate stuff with power supplies and loads. It's almost impossible to simulate the crank of an engine because it's such a dynamic current draw. You really can't duplicate it unless you've got a couple of $100,000 to spend on equipment. So the real world testing is by far the most valuable.
Yeah. All right. Thank you very much, Tim. And thank you everyone for watching. And I hope this is going to be a great success. It's ticking all the boxes for me. So well, let's see how we go.
Absolutely. Appreciate any feedback. The early adopters that we get, our customers, one of the things we'll be encouraging to do is let us know how they go, give us some feedback. That's highly valuable and help us understand how they perform and maybe other features we could bring in the future that might make it even better.
Yeah. Cool. All right. Thank you very much for watching, everyone. We'll cut it off there, I think. That's been long enough. It's been a great in-depth look at the battery and what it can do. And, it's going to be awesome. Thanks for watching, guys. And until next time, bye for now.